Now that we've covered the various components of CloudGuard workload protection that can be deployed to help protect containers, let's roll up our sleeves and start deploying. Deploying CloudGuard container security is rather straightforward. We will synchronize CloudGuard and the Kubernetes cluster by deploying a CloudGuard agent onto the cluster, which reports information back to CloudGuard. On top of that, we will have to configure the admission controller component from scratch to create default access rules. For the sake of this session, we're assuming you already have a Kubernetes cluster set up, as this is out of this program's scope. To begin, we log into the Infinity portal and navigate to the Assets section under CloudGuard. Here, we need to connect CloudGuard and the Kubernetes cluster we wish to protect. We start by adding a new Kubernetes cluster environment. If this is the first time we're adding an asset, we'll get this Get Started screen. Otherwise, we'll add a new environment into the existing list of environments. We fill in a meaningful, unique name which will be used to identify the Kubernetes cluster within CloudGuard. Next, we create a new service account which will generate the account API key ID and secret. These will be used to identify the API calls from CloudGuard's implanted agent in the cluster to CloudGuard. It is important to keep a record of these details for future reference. Note that you can also use an existing service account. In such a case, you'll be using the API key ID and secret on record. Next, we fill in the Kubernetes namespace as defined in our target cluster. We make sure to mark the desired features we'd like to make available. Now, we choose the relevant organizational unit to associate with a cloud account. Organizational units help us view and maintain onboarded accounts according to logical groupings, such as business units or geographical regions. Next, we open an SSH connection to the designated Kubernetes cluster and paste the Helm commands from the instructions summary in the SSH connection. These commands deploy the CloudGuard agent within the cluster. Once done executing, the status will be deployed. Clicking the Next button will verify that both systems are synchronized. This synchronization means CloudGuard accesses the cluster through the agent to obtain information about the assets. To finalize, we hit the Finish button. This completes the deployment. We now have our CloudGuard workload protection deployed and synced with our Kubernetes cluster. Let's look at what we have here. Under Protected Assets, we can view the onboarded account's assets. CloudGuard fetches information about these assets from the onboarded cloud platform and presents it in a console view. CloudGuard monitors the security posture of these assets. Drilling down into a workload asset, we can view its protected processes, define exclusions to the default runtime protection rules, and find any special security findings and events related to the asset. Conversely, we can access the protected components through workload protection. Here, we can view and drill down into all containers being protected across the board. Under Image Assurance, we can locate the images being protected, view any detected vulnerabilities, and examine and modify the default policy and rules. Here, we can view and drill down into all the pod groups runtime protection is applied to across the board. Under Admission Control, we need to create a first-time rule set, as the deployment does not create a default policy. This process consists of 3 steps: adding an admission control rule set, adding rules to the rule set, and adding an admission control policy that binds the rule set to the cluster. Let's add an admission control rule to prevent services from being publicly exposed. Naturally, your use cases can differ depending on your architecture and business needs. We start by adding a rule set and naming it. Now, we add a new rule into it. When we click inside the GSL box, the GSL editor opens up. CloudGuard GSL, which stands for Governance Specification Language, is a simple yet expressive syntax to define rules, which can be included in rule sets in the CloudGuard compliance engine. The use case option covers the most popular scenarios for the admission control rule set creation. In this case, we add this pre-built rule. You can see the GSL syntax change as we further configure the rule. Finally, we verify the rule against the relevant environment and save. Now, we need to bind the rule set to the relevant cluster. So we head out to the policies and either associate it with an existing policy or with a new policy. In our case, we'll create a new policy. After defining which entities it applies to, we need to choose one or two actions to take when the rule or rules within the policy are violated. Either detection, where the policy does not block events on the cluster but sends an alert notification, or prevention, where the policy blocks an event that violates it on the cluster and sends an alert notification. It's best practice to first use detection with new policies. If needed, you can configure multiple policies on the same cluster with a different action configuration. Finally, we define one or more notifications to receive when the policy is violated.